All right, welcome everyone. In this video, I want to talk about how we can construct a bootstrap confidence interval from a bootstrap distribution. So the goal of a bootstrap distribution is to get an approximation for a sampling distribution. And recall, we can use sampling distributions to construct confidence intervals. In our case, since we're using a bootstrap distribution as an approximation for the sampling distribution, we call this a bootstrap confidence interval. And as with regular confidence intervals, we have a confidence level that we can attach to the estimate. And the most common confidence level to choose is a 95% confidence level, but we can choose other confidence levels, and we'll take a look at that. And the confidence level of a confidence interval tells us the odds of success. What are the chances of success? So for example, a 95% confidence interval tells us that the confidence interval that we get has a 95% chance of actually containing the population mean that we're trying to estimate. So it's giving us our odds of success. So if we want to construct a 95% bootstrap confidence interval, let's say I've got some bootstrap distribution, and that's what we're looking at in this image. And this bootstrap distribution doesn't need to be normal, and it doesn't even need to be symmetric. In this case, the picture does look kind of normal, but these bootstrap distributions can be skewed. And what we want to do is we want to construct an interval that contains 95% of our bootstrap resamples. So what we're going to assume is kind of like the population mean is one of these values that we get in our bootstrap distribution. So we're going to construct an interval that contains 95% of the bootstrap resamples, and that's going to have about a 95% chance of containing the actual population mean. So I have my bootstrap distribution. I want to contain the middle 95% of the values. So that means we want to exclude 5% of the values that are not going to be in that green area. So we get rid of the 2.5% of the smallest bootstrap statistics, and we get rid of the biggest 2.5% of the bootstrap resamples. And then what's left is the 95% of the samples in the middle. So this 2.5% comes from the fact that if 95% are in the middle, 5% is not in the middle, and we split that 5% evenly in the lower tail and the upper tail. So that's what's going on here. So the endpoints of a 95% bootstrap confidence interval we find by finding the 0.025 quantile of the bootstrap distribution. This tells me the lower cutoff. And then I find the 0.975 quantile of the bootstrap distribution, and that tells me my upper cutoff. So once I have my bootstrap distribution, I just want to pull off the quantiles corresponding to the cutoffs for my confidence interval. And in the end, we get an interval. And that interval just gives us a range of plausible values for an unknown population parameter. And when we kind of interpret the meaning of a confidence interval, since different samples would lead to different interval estimates, the uncertainty of our estimate, we just want to make sure that we attach that to the interval that we've constructed, which is variable. And we don't attach that odds of success, that uncertainty, to the parameter that we're estimating, since the parameter that we're estimating is not variable. It is a fixed value. It's just an unknown value. So when we interpret these confidence intervals, we typically say that there's a 95% 95% chance that our interval estimate is going to contain the population parameter. So in the next video, we'll use this bootstrap distribution for the golden jackal jaw lengths to construct a 95% bootstrap confidence interval to estimate the mean jaw length of all golden jackals.